Okay. So I hope that I'm visible and my presentation also. Glad to be here. Thank you for the invitation. I will be talking about tools for explainable artificial intelligence. And I think it's especially important to say that I will be showcasing not only my work, but also the work of my colleagues. So Marcin already introduced me, so I can just say that I'm working as a research software engineer, and I'm developing the explainable AI tools, which is somewhat connected with my data science studies. And as Marcin mentioned, we'll be talking today about some packages like DALEX and Model Studio. Before talking about the tools, I would like to briefly touch on the semantics of the explainable AI term. I would say that the AI community is divided into people that use this phrase and the people that avoid it while still doing explainable AI. To understand what might be the agreed meaning of this term, I Googled explainable AI plus insert your favorite company researching AI. For IBM, it means a set of capabilities and methods used to describe an AI model, its expected impact and potential biases. Okay, so we have described an AI model, but also something about the bias. Now, Microsoft is especially focused on using the model interpretability term, especially near their tools for XAI. But here we see that it is further described as using interpretable models and explaining black box machine learning. Here are other tags used by Microsoft to describe their tools, especially the XAI, explainable AI, artificial intelligence, and bias. I believe that the model interpretability term is really popular among the deep learning community. Hence, it's also used by Facebook to describe their tools. As we can see, they publicly state that their tools are part of explainable AI frameworks, so it overall makes some sense. For me, and especially for the context of this talk, the best definition would be by Google. When you actually Google explainable AI plus Google, we can read that these are tools and frameworks to understand and interpret your machine learning models. And with this definition, we shall proceed. One of the milestones in the development of the explainable AI domain was the project conducted by Defense Advanced Research Projects Agency. It's a USA government platform which finances a lot of AI research. And about 4 years ago, it published a program for researchers to finance the development of explainable AI tools. Now we are at the point where explainable AI is somewhat mature enough to be commonly used in the model development process. The question is, who is the user? To answer that, I would like to use the graphics from one of my favorite XAI papers, which I can recommend even to people who are not interested in research, because it's well written and summarizes the domain. I would say that the main users of explainable AI are still the machine learning practitioners trying to understand and improve their models. And then there are domain experts, especially medicine and finance domains come to mind. They want to gain trust into AI solutions and discover something new, gain scientific knowledge. Nowadays, it's more and more important for managers and regulatory entities to understand how AI works, since governments and policymakers enforce new rules, guidelines, even laws on the use of AI. Most notably, the quote-unquote right to explanation. Lastly, I highlighted the user group as it's, in my opinion, the most overlooked audience. Unfortunately, without these regulations, not many companies that use AI think about how it affects the end user. Okay, so now we know more about the explainable AI domain. Let's introduce some tools. Here I present the brief summary of machine learning model explanations. Overall, it's a lot to digest. The summary written by my colleagues can be found at xai-tools.DrWhy.AI. The key idea is that we can divide these tools into three categories. First one is using interpretable models that are somewhat more transparent. They aren't really black boxes. Then we have the second group, which is model-specific explanations. They are tailored for one algorithm. Maybe it's neural networks, and then we only use a specific model explanations to explain neural networks. Finally, the third category are model-agnostic explanations. These can be applied to any machine learning predictive model. They truly explain the black box. So from now on, I will be focusing on model-agnostic explanations as they can be applied to any machine learning predictive task. With this in mind, we developed the DALEX package. First R package and now also the Python package. DALEX is a model-agnostic explainable AI toolkit which aims at explaining any predictive model. Of course, there are multiple ways that we can tackle this problem. Starting from choosing to explain the model at instance level, meaning looking at one particular observation from the data, or explaining the model at dataset level, meaning looking at the overall behavior of this model. These levels are often called local explanations, where we focus mainly on one observation and sometimes its neighborhood, and global explanations, where we want to understand and interpret the machine learning model as a whole. To introduce some of the explanations, I will use a simple machine learning task, which is predicting country happiness score. It's available on Kaggle. The variables are statistics describing each country, for example, mean life expectancy or government social support. The target is happiness score on a scale from 0 to 10. It doesn't really matter which predictive model we choose. It can be any black box really, because I will be talking about model-agnostic explanations. The first type of explanations, and probably the most intuitive, that can be found in the DALEX package, is explaining parts. Here on the left, we see an example of explaining prediction attributions for a given observation. This can be breakdown plots or more popular sharp values plots. For example, the prediction of happiness score for the Poland country is over 6. The mean prediction is about 5.5, and we can break down this prediction into parts. And we can do that for each observation. When we think about instance level explanations, we use the predict word. But when we think about dataset level explanations, we use the model word. On the right, we see one of the most popular explainable AI methods, which is feature importance. For example, the permutational importance or aggregated sharp values. By the analogy, they show the importance of model parts in respect to given measure. The second type of explanations that can be found in the DALEX package is explaining the profile. The same taxonomy applies. On the left, we see an example of explaining prediction profiles for a given observation. These are ceteris paribus profiles, also called the what-if plots. For example, we can see what would happen if we change the value of social support variable for a given country. We want to see how the prediction would change for a given observation if we change the value of the variable. Now, on the right, we see an example of explaining model profiles for a given dataset. In the most basic form, it would be averaging the prediction profiles for all of the observations in the dataset. So let's say we have 500 these prediction profiles, and we average them, and this is the partial dependence plots. Actually, the partial dependence plots are so popular that they are included in the scikit-learn machine learning framework. There are, of course, more explanations in the DALEX package. I just wanted really to emphasize the division into predict methods, which operate on an observation, and model methods, which operate on whole data or its representative subset. Now let's look at the structure of the Python DALEX package. At the start, we have the model. It can be any model really, granted that the user provides a proper predict function. Then there is data. Since we are not explaining the model in respect to the data, it's strongly advised to use pandas data frames and actually name the variables, because without this, you won't really have an understandable explanation. Model and data is provided to the main explainer object, which will detect the proper predict function as well as the model task type. It might be classification, it might be regression. Some methods may work differently for different tasks. This explainer object then provides a unified interface to explain your machine learning predictive model. One can use many methods to produce explanation objects. Some methods also have multiple types available. Finally, when we compute the explanation object, the interface is rather simple. There is a result attribute, which is the computed explanation in the form of pandas data frame, as well as the plot method, which visualizes the explanation. Now let's see how this works in practice. Once again, introducing the basic concept of the DALEX package. Provided data and the model, we produce the explainer object. After the creation, we are presented with the formatted output that describes information about the model and data. It's what the DALEX package understood from the provided parameters. The most important here is the predict function. This output will tell us if the predict function actually works as intended, and there will be no problems with using methods and other explanations. Here, I would like to introduce the three basic concepts of the unified interface, taking the model level explanations as an example. One can use the method to only produce the explanation object. Here we see the easiest way to examine model performance. We just use the model performance method and we are presented with the data frame with all the default measures. We can also use the result attribute to get the computed explanation. Here on the example of model parts, we see a pandas data frame with the attributions, the model parts. Finally, you can plot the explanation using the plot method. So these are the basic concepts. For predict level explanations, we need the actual observation from the data. So this is another parameter, another variable. One can ask a question, why is this prediction A, not B? And as with every explanation object, we have the result attribute and the plot method to visualize this result. Another question would be, what if the value of any given variable changes? Providing the observation to the predict profile method, we choose to plot this explanation. Of course, there are more methods and even more types of these methods. The DALEX package provides residual diagnostics. It also has a method for fitting an interpretable surrogate model, which learns on the predictions of the black box model. And then this surrogate model can be plotted, for example, as a decision tree. Finally, the DALEX package also provides an interface to produce the popular explanations from the very, very popular SHAP and LIME packages. For example, the predict surrogate method explains the prediction for one observation using the LIME package. A great step to start your journey in explaining machine learning predictive models is a book by Przemyslaw Biecek and Tomasz Brzykowski, Explanatory Model Analysis. Apart from describing many model-agnostic explainable AI methods, there are R and Python code examples using the DALEX package. My favorite feature of this book is that apart from the math theory and the practice code, it also explains the intuition behind each of these explainable AI methods. We have developed more packages that implement various explanations. The DrWhy.AI is a collection of R packages for explainable AI, or model interpretability, as some might say. DALEX serves as an adapter for machine learning models and frameworks so that they are presented in a unified way for other tools. There is an easy to remember link to GitHub. If you want to dive deeper, it's just DrWhy.AI. For me, one of the more interesting tool from DrWhy.AI is the Vivo explanation method. It's just another way of calculating variable importance. It's based on partial dependence profiles. The main idea is to somehow measure the change rate in the profile. In particular, the larger influence of an explanatory variable on prediction, the larger the deviation along the profile. We can argue that for an unimportant variable, for example, this profile will be rather flat and show no change. The intuition stays the same for local and global variable importance. You measure the presented area and plot it as a bar plot. Of course, there are many ways of calculating this area, thus the package has a lot of parameters to customize that. If you are looking for an alternative way of calculating feature importance that may be faster than permutational importance and also has no random component, I would advise you to use this package. Okay, now let's ask ourselves what's next. Is the DALEX package and other tools the end solution that really satisfies all of the targeted audience? The audience that I was talking about in the introduction? It for sure can help machine learning engineers, researchers, data scientists, and artificial AI companies. But what about the domain experts and other users? Here we defined a progress of explanations. First, there were black box AI models that we couldn't really understand. Then we developed explainable AI tools to overcome this issue. Also, by the way, the DALEX package falls into this category. But for us, the next generation of explainable AI tools will add the interactive aspect to XAI. And what is more important, there will be multiple XAI methods presented next to each other and complementing each other. For that, in our paper, we show examples of model explanations and data exploration techniques that can benefit from each other. We call it an interactive explanatory model analysis. Okay, we defined a framework, but what about the topic of this talk? The tools for explainable AI. The tool that makes this idea a reality is the Model Studio package. It creates a dashboard for interactive explainable AI. This dashboard consists of various model explanations and also data exploration techniques. One can freely change the grid of plots to suit their needs. There is a possibility to explore multiple observations and variables. What for me was the most important while developing this package is the full automation of the dashboard creation. So the user doesn't need to code these explanations. This dashboard is serverless. It's just an HTML file that can be easily saved. One can, for example, save one dashboard per each version of the model. Because of its simplicity and the serverless architecture, this dashboard can be easily shared with others, maybe in your team, or just computed in the cloud and then sent to you by email. For example, you can send this dashboard by Slack or attach it to the model documentation. Here, I just wanted to highlight what it takes to create such dashboard. We can see that it's rather convenient. This package is mainly for R, but in the documentation, you can also find the examples of how to port the Python models using the DALEX Python explainer object into R to create this Model Studio dashboard. Here we see the same pipeline that we are using in the DALEX package. We have data and model, we provide it to the explainer object, and after that, the only thing you do is use the Model Studio function, and this function will compute all of the explanations that you need, and then present you with the constructed dashboard in the form of the HTML file. So actually, I hope that you can see now the computed dashboard. And what I can do here is use all of the explanations that I introduced before. So I might choose the what-if plots, maybe some partial dependence profiles. I will decide to also explore the data. Now I'm not really interested in Poland. Maybe we can choose some other country. Let's see what happens with Norway. What are the attributions for each of the variable to the prediction? And also we can change these variables, and all of the visualizations will change with that. And this solution was introduced so that we spend more time explaining our models and exploring our data, and not like coding these explanations. Okay. But this is in R. Maybe someone doesn't like R. Even better explainable AI tool created in our lab is the Arena. It could really make a lot of good for you when explaining machine learning predictive models, especially comparing multiple models. I would say that this Arena dashboard is a model studio on steroids. You can explain multiple models and validate them on multiple data sets. There are more plots available for you, for example, some fairness measures, and also more data exploration plots. There are multiple pages that you can use to save your explanations. It also saves in cache, and it also can be serverless, the same as the Model Studio dashboard, if you choose so. The Arena package first was introduced in R, but now in the next version of the DALEX Python package, we'll have the backend for the Arena dashboard in Python. So you'll be able to calculate all of the explanations in Python and then just import them in the Arena dashboard and freely explore your models. To sum up, I would say that we have a good set of tools for explainable AI, and what is even more important, they are somewhat convenient. At least I would like to believe so. I showcase one of the latest Gartner Hype cycles. If you are not familiar, these plots present various stages of the technology cycle, from the innovation stage through the peak of the domain, into the stable productivity stage. We can see that the explainable AI is already advanced, and we have developed the needed tools. The next hype train will probably be the responsible AI, which, apart from the explainable AI, aims at embracing the responsible approach to machine learning. The ideas are developing fair models, secure models, robust models, and so on. Model fairness and model bias has become a hot topic nowadays. The policymakers more and more talk about guidelines, laws, and regulations on AI. With this responsible AI idea in mind, we developed the Fair Models R package, which is a flexible tool for bias detection, visualization, and mitigation. It also uses the DALEX explainer, the same as all of the packages from DrWhy.AI. Fair Models is a good way to compare and gain information about potential unfair or biased machine learning models. There are also some techniques implemented for pre- and post-modeling bias mitigation. I would say that Fair Models is a great solution if you are working with classification models and really need to check for biases in your models. This is currently an R package, but we have added the base functionalities of this package into the DALEX Python package in the fairness module. Here, I would like to introduce you to the basics of fairness check. As the name suggests, we aim to check if our model is fair. For that, we need to provide the protected variable. It should be a categorical vector with subgroups, which will be used to calculate fairness metrics. It's worth pointing out that this protected variable can be any variable really. It doesn't need to be used in model training. Because sometimes we feed the model, and actually there are some harmful relationships invisible to us, which the model will learn, and it might get biased. The second parameter needed to fairness check is the privileged subgroup. So, for example, it might be a white young male as myself. We use the unified interface of the explainer object. It's a model level explanation, and we are interested in fairness, so we use the model fairness method. The explanation, of course, has the usual result attribute and the plot method, but the main functionality lays in the fairness check method. It will automatically tell us if the model is fair by printing its reasoning. These are mostly the equality ratio fairness metrics. The plot method will visualize the fairness equality metrics and highlight the 4/5 rule, which was chosen as some standard that can be used to check if the model is fair. Here we see that some metrics did not meet the criteria, which can suggest that the model is biased. Can, but doesn't need to be. Because of the rising popularity of the domain, I would like to invite you to the Responsible Machine Learning blog, which we started in our lab. There are various news, guides, examples on the explainable AI and responsible AI topics. Follow this blog if you are interested or in these topics or would like to know more about the tools I presented today and also about the future releases. I hope that you have found these ideas useful. On a final note, all of you can contribute to these packages, and the best way to do so is going on GitHub and creating an issue with a feature request or bug report.